Welcome to another demonstration in physics. Today I'm going to demonstrate the concept of equipotential lines using this simple setup that you can replicate at home. So we have a multi-tester for measuring the potential difference, a plastic container filled with water and salt solution, and an AC-DC converter to provide the direct current for this setup. If you notice, I oriented the plastic container this way. The reason is that I want to create an analog to the gravitational field. Okay, we can imagine or we can visualize the electric field pointing from the positive terminal downwards towards the negative terminal. We can compare this to the gravitational field. Alright, if this is the ground here, this portion, then the gravitational field points downwards towards the ground. Like a mass particle in a gravitational field, charged particle also gains or loses potential energy in an electric field relative to its position. Electric potential energy is equivalent to the amount of work done in moving the charge against the electric field. Assuming natay positive charge from infinity, dayon atong gilihok towards a source charge. Okay? No, from infinity towards a source charge. Then the charge na atong gilihok towards the source charge will experience increasing repulsive force and gain potential energy. When we release the charge, the electric field does work on the charge and the charge gains kinetic energy. In this case, in our setup, if natay positively charged particle, gikan aning negative side, then atong gi-move towards the positive side, then the particle gains electric potential energy. If i-release nato ang particle, then it will accelerate towards the negative side. Same thing happens to a negatively charged particle if atong i-move from the positive side to the negative side. Ma-compare nato na siya sa gravitational potential energy in which na ang object, if ato siyang i-move, okay, pasaka, gaining height, then it gains potential energy. If ato siyang i-release, mag-lose siya potential energy, gaining kinetic energy. Of course, ma-observe nato na because of its increasing speed. The electric potential or voltage is simply the amount of potential energy per unit of charge at a specified location. Electric potential is a location-dependent quantity. Also, when work done on the charge, its position changes. So the difference between the final and initial position of the charge is the electric potential difference. Here in this setup, we can visualize the electric field pointing from the positive side to the negative side. This multi-tester, when we set it to voltmeter, we can measure the potential difference between any points here. So in fact, the voltmeter operates by measuring the potential difference. So let's try now measuring any potential difference. Now all we need to do is to point these probes, immerse these probes in the water. Okay, ako sa siya i-entangle. Okay. Here. So notice if there is a deflection. Okay, there is no deflection yet. Okay. Wala man din na open or na turn on ang converter. Alright, here. So notice that there is a deflection. Okay, we note that the closer I move the probes towards each other, okay, look at this one, the smaller the potential difference becomes. Now, for example, we put the probes in this position. What is the reading? So, unsay reading ani? Okay, ang reading ani is nasa 2 and 4. Anyway, we can change the sensitivity or the range of this multi-tester aron mas maklaro ang reading niya. Okay, I'm going to put that to 10. Okay, range is 10. If we put the probes in this position, okay, what is the reading? So the reading is 2 volts. Okay, that means we have a 2 joules amount of work is done by the electric field in moving a charge from this point where the red probe is, okay, from this point, the point where the black probe is. So ang butay pasabot ani, basically, if we allow the electric field to move a unit of charge, let's say 1 coulomb, okay, 1 coulomb from this point towards that point, then the work done in doing that by the electric field is 2 joules, okay, per unit of charge. But there are parts here where we cannot find any potential difference. Okay? Natanawa gali. Na yung mga parts diri na walay potential difference. Here. If you notice, okay, wala tayo na-observe na deflection sa needle. Notice no matter how far we move the probes from each other, the reading is still 0. Because we are traversing the equipotential lines. That means in this line, the potential is constant. Okay, therefore, no difference. Unsa man ang equipotential line and asa man nato na unsa may analog ana sa iya ha. We can compare that to a flat plane. Okay? So flat plane in which walay change in height. So kung walay change in height, that means there is no change in the potential energy or gravitational potential energy of an object. Ana. So and also if nakakita na mo ginatawag na contour maps, di ba ang contour maps manotice ninyo na naay mga lines dira, okay, mga lines. Kana na mga lines, okay, that represent, okay, same elevation. And kung same na silang elevation, then wala change in potential in traversing those elevation or na lines. Now, since this is a flat plane setup, we observe equipotential lines. Now, if we could do this in 3D or 3-dimensional, we would be observing equipotential surface or equipotential surfaces. Now, there are many equipotential regions here. So, nata right here, another, okay, right here, another one here, and another one here. If we can trace the paths we traverse, where there are no potential differences, then it would look like this. Okay, now that's it for equipotential lines.